These different types of roads can really help us understand some of the relationships we're going to see between lines. So in one case right here, you can see that we've got a pair of roads that are running exactly in the same direction as one another. And so whenever we have lines that go as such, we denote them as parallel. And then in the other cases, in both of these cases right here, you can see that the two roads are going to cross one another. And so whenever we do have two lines that meet at least some point, we can say that they are intersecting one another. So that's happening in both cases. Now this case right here is a little bit more special than the other one in that they're not only crossing, but when they do cross, they form 90-degree angles. And so whenever two lines make a 90-degree angle with one another, then we denote them as specifically being perpendicular with one another. So first of all, focusing in on the parallel line aspect of things right here, to be able to determine whether lines are parallel with one another, you need to justify that and prove that, and the way that we know lines are parallel is if they have the same slope. So right here it appears, right, like the lines are going to be parallel to each other, but you can't just say that just based on how it looks. You actually have to prove that, and you can do so using the slopes. So if you found the slope of this red line right here, you can see that it's going to have a rise of 1 for every 2 units of run, so the slope there would be 1/2. And then you have to check the slope of the blue line, so it does turn out that also you do have a rise of 1 and a run of 2. So therefore, now that we've actually shown that the slopes are the same, then you can prove that the lines are parallel. So we can summarize and say that for any two distinct, so different, and also non-vertical lines, they are always going to be parallel if and only if their slopes are equal to one another. So the reason why we break this apart into non-vertical line cases and then vertical line cases is because if you do have two vertical lines, of course they're going to be parallel to one another, but we can't say that their slopes are equal because the slopes of those two lines are undefined, and undefined is not a number, so you can't say undefined equals undefined because undefined again is not a number. So that's why we just have this separate bullet point just to say that any two vertical lines are parallel. But really you can just think more simply, of course, right, that any lines with the same slopes, as long as they're not the same line as each other, are going to be parallel. So in example here, we're just asked, are the lines shown in each graph parallel, and justify your answer. So you can't just say yes, no, they are parallel, and you can't just go off the looks. You have to prove that, and you can prove that just by showing their slopes are the same. So this line right here, it's actually called line 2, as you can see right there. If we're to find the slope of that, we can find the change in the y. So how about we do 3 minus -4 to do so? And then we'll have to start with -3 for the x's and subtract away this -1. So we end up getting plus there and plus there, so you're going to end up with a 7 over -2 for the slope of line 2 there. And then for line 1, if we find the slope, we'll do rise, which is 5 minus -4, and then run, which will be -1 minus +2. So we do get plus there, so we're going to end up with 9 over -3, and that does reduce down to -3 for a slope. So when you do compare those two slopes with one another, they are not equal to one another. So those lines actually have different slopes, which means they will actually cross each other at some particular point, just not shown in the graph. So what we'll be able to conclude from this then is that line 1 and line 2 are not parallel, and there's a symbol that we use for parallel or not parallel. So if they were parallel, you just draw kind of two lines like that, like sort of like railroad tracks basically, but in this case they're not parallel, so then you just draw a slash to the symbol, and that'll tell you that line 1 and line 2 are not parallel to one another. Whereas in this case right here, notice that the x-axis and y-axis are labeled by 2's. So like when I find the rise right there, that's actually 6, and then 2 plus 1, which is 3. So you get a slope right there, which is 6 over 3, which equals 2. And then similarly, you're going to go up 5 plus 3, so that's 8, and then 1 plus 2 plus 1, so that's 4. So you get a slope there of 8 over 4, which is equal to 2. So in this case, the lines do actually have exactly the same slopes as one another. So what we'll be able to say about this then is if this is like line A and this is line B, then we can say that indeed in this case that A and B are parallel.